So for today's lesson, I thought it would be easier to just go over the answers to what you guys should have solved in yesterday's lesson because there's some patterns that emerge that are very important. So first off, when you're looking at cones, pyramids, and cones and pyramids, if you go parallel to the base, if you cut this parallel to the base, you're going to get the same shape as the base. Like a rectangle here for the rectangular one, a triangle here for the triangular pyramid. However, it's not going to be congruent to the base. All of these shapes are going to be similar to the base. Because if you think about it, this base here, this circle at the bottom, is obviously larger than this circle right here. And it'll get smaller and smaller the higher up you cut it, and bigger the lower down you cut it. So, that's always true. When you have a pyramid, any cut parallel to the base makes the same shape as the base, but it's similar, not congruent. Also with a pyramid, if you cut perpendicular through the base, right through the middle, what you're going to get every single time is an isosceles triangle. And if you just think about like looking at a pyramid from its side, it kind of looks like a triangle if you like make it into a 2D projection of the 3D shape. Now, with the prism, you can see here that this prism, has a triangular base. And when you actually make the parallel cross-section cut, it's going to be the same exact size and shape as the original base. Because it just goes straight up. It doesn't like cut in and get smaller as it goes towards the top. It's just the same size for each one. So you're going to get the same exact shape congruent to the base if you cut parallel. And if you cut perpendicular with a prism, you're going to end up getting a rectangle each time. So you can see here with the rectangular prism and the cylinder, both kind of prism-like things, you get a circle that's exactly congruent to the base, and here you get a rectangle that's congruent to the base when you cut parallel to the base. And if you cut perpendicular to the base, each time you're going to get a rectangle. And with the sphere, you're just going to get a circle each time. Now, down here, looking at this reflection question, it's asking for the area of this cross-section right here. And I said that the area is larger than the area of the cube's face. And here's the reason why that's true. If this is a cube, all the sides are the same. So let's call them, I don't know, we'll call them 1 foot or whatever. So like if that's 1 foot and that's 1 foot, that would mean that this is 1 foot. So our area is 1 times something. And the something we have to figure out is right here. And the way you'd figure that out is you look at this right triangle right here, and that's your hypotenuse. You do 1 squared plus 1 squared for these two legs here equals x squared, and then you get 2 equals x squared. Take the square root, you get radical 2. So the area of this cross section right here is 1 times radical 2. And radical 2 is going to be bigger than the area of one of the faces, which is just 1 times 1.